In last class we have seen one sample set test. In this class we will see some more problems on one sample Z test. A study claims that Indian smartphone users spend 3.5 hours a day on their smartphones. Try to verify this with following summary data. Population standard deviation is 2 hours. Sample size 121. Sample mean 3.7 hours. We need to test the hypothesis at 99% confidence level. Means alpha will be 0.01. Study claims that Indian smartphone users spend 3.5 hours a day. It is the hypothesized mean, mu naught. So here is the data we have. Mu naught is 3.5 hours. We need to test here based on the sample mean 3.7 hours whether all Indian users spending 3.5 hours on their smartphones or not. First step, we need to formulate null hypothesis and alternate hypothesis. Here null hypothesis will not differ with the mu naught, so h naught mu equal to 3.5, h1 mu naught equal to 3.5. We need to test our hypothesis at 99% confidence level, so alpha will be 0.01, means 1% of times we may falsely reject the null hypothesis. Third step, determine appropriate test to use. Here we can use a Z test because we know the population standard deviation, which is 2 hours, and here sample size is 121, so we can go for one sample Z test. Now calculate the test statistic. Z statistic equal to x bar minus mu naught by sigma by square root n. X bar is 3.7 and mu naught is 3.5. The difference is 0.2 and standard error 2 by square root 121 is 0.18. Now our test statistic is 1.1. This means the sample mean 3.7 is 1.1 standard error units from the population mean 3.5. Determine one tail or two tail test. See this alternate hypothesis. Here we have rejection region will be on both sides, either less than 3.5 or greater than 3.5. We can reject the null hypothesis. This is the two tail test. So find the Z critical value for two tail test for 99% confidence level. Alpha will be 0.01. It is two tail test, so distribute your alpha on both sides equally. It will be 0.005 on left side and 0.005 on right side. Find the Z score for this probability value in Z table. 0.005. This is the probability value. Z score is minus 2.57. Even you can see here for 99% confidence level, alpha 0.01. It is two tail test, so Z value is 2.575. Left side minus 2.575, right side 2.575. This is the Z critical value. Step 5. Compare test statistic with Z critical value for desired confidence level. We already found that Z critical value for 99% confidence level, it is minus 2.575. Here on right tail Z critical value 2.575, left tail minus 2.575. Our Z statistic is 1.1, which is between these two critical values, means which is falling in the 99% confidence interval, means which is not falling in the rejection region. If Z statistic falls within the rejection region, you will say that results are significant, but here which is in the acceptance region, so results are not significant. So we cannot reject null hypothesis. So this statement is not true because we are unable to reject this null hypothesis. We can even use p-value for testing hypothesis. Find the p-value at this 1.1 Z statistic value. See the Z table. Z statistic value 1.1 because Z tables are symmetric. So you can see either left side or right side probability value will be same on left side and right side. Here it is cumulative probability. Instead of just taking this value and subtracting it from the 1, we can go for minus 1.1. Here the probability value is 0.13567. It is one tail p-value. So to find the two-tail p-value, just multiply this value with 2. You will get p-value for two-tail test 0.271. We have to compare this p-value with the specified alpha. Alpha here is 0.01. P-value 0.27, not less than 0.01. If p-value less than alpha, then you can reject null hypothesis. But here it is not less than alpha. You cannot reject null hypothesis. See here, significance level is 0.01, p-value greater than significance level, so results are not significant, so you cannot reject null hypothesis. We can use confidence intervals to test the hypothesis. Let's use confidence interval to test that hypothesis. Confidence intervals can be calculated by using this formula. X bar plus or minus this margin of error, this z alpha by 2 is the critical value, sigma by square root n is standard error. Critical value for 99% confidence level for two-tail test is 2.575. So sample mean is 3.7 and critical value is 2.575. It is 5, and population standard deviation 2 by square root sample size, it is 121. If you calculate this value, then you will get the lower bound 3.23 and upper bound 4.16. This is the confidence interval range for 99% confidence level for this sample mean. See here, sample mean is 3.7 and lower bound is around 3.23 and upper bound 4.16. This mu naught between this upper bound and lower bound, it is 3.5, so you cannot reject null hypothesis. Let's take another example. In particular geographic region, in reading tests, the mean and standard deviation of scores are 100 points and 12 points respectively. In particular school, the mean score of 55 students is 96. We need to test whether these school students have the lower scores than these region students at 95% confidence level. This is our data. Population standard deviation is 12 points. Sample size 55. Sample mean school student reading test score mean is 96. Population mean mu naught, which is the region mean score, 100 points, and alpha level is 0.05. First step is to formulate null hypothesis and alternate hypothesis. Here we need to test whether these school students having the lower mean scores than regional students. Regional student score is 100 points, which is the mu naught, and null hypothesis will be mu greater than or equal to 100, or alpha level is 0.05. Here we can use one sample z test because we know the standard deviation of the population and the sample size is greater than 30. So we can calculate z statistic by using this formula. It will be 96 minus 100 by standard error 12 by square root 55. The z statistic is minus 2.47. This sample mean 96 is minus 2.47 standard deviations from population mean 100. Here this test is left tail test, so we have to find the z critical value for left tail test for confidence level 95. For one tail test 95% confidence level, the z critical value is 1.645 because it is left tail test minus 1.645. Compare the z statistic with z critical value. Here z statistic is minus 2.47 and z critical value is minus 1.645 because z statistic falls within the critical region, so results are significant, so we can reject null hypothesis. Means this value, z statistic value, is very unlikely in this null distribution, so we will reject the null hypothesis. By using p-value, first we need to find the p-value for this z statistic minus 2.47. P-value means you have to calculate the probability value from this z score to the end, means to minus infinity. Let's check the p-value from z table. Here these tables are from minus infinity to up to z, so you can check the probability at minus 2.47. It is here 0.0676. It is approximately 0.068. This is the p-value 0.068. You need to compare this p-value with alpha. alpha here is 0.05, p-value less than alpha. So results are significant. You can reject the null hypothesis. If p-value is more than this alpha, you cannot reject null hypothesis. Means if this green region is up to here, means observing that particular z-score will be having more probability, then you cannot reject null hypothesis. But here observing this minus 2.47 z-score having very less probability, so this is very unlikely in this null hypothesis, so you have to reject null hypothesis. This is true here. By using confidence intervals, calculate the confidence interval. But here this is a one-tail test. You have to find the z critical value for one tail. Our alpha level is 0.05 and one tail test z critical value is 1.645. So substitute this 1.645 at this z alpha. Sample mean is 96 plus or minus 1.645. Population standard deviation 12 by square root of 55. This is the sample size. If you calculate this value, then you will get lower bound 93.34 and upper bound 98.7. Since it is left tail test, you have to consider only upper bound, and we don't need this lower bound value and replace that with minus infinity. So confidence interval for the sample mean 96 for left tail test is minus infinity to 98.7. Population mean mu naught is 100, which is not within the this confidence interval range minus infinity to 98.7. So we will reject the null hypothesis. You may get doubt why we are taking only upper bound. Suppose sample mean is 150, then if you construct the confidence intervals, it will be lower bound 147.34 and upper bound 152.66. According to null hypothesis, mu greater than 100, which is a valid score, but your mu naught not within this confidence interval. If it is two-tailed, then you have to consider this upper bound and lower bound. But here, this 150 is valid score. So, if you remove this lower bound and place it with minus infinity, then your mu naught 100 will be within this confidence interval range. So, it will be treated as valid score. And take another example. Suppose mean score is 50, sample mean. Then confidence interval will be 47.34 and 52.66. In this case, if you remove this and place with minus infinity, anyway this upper bound 52.66 not covering the population mean, so this mean score is not acceptable in this null hypothesis. Means we have to take the sample mean and you have to consider some margin of error, so you have to subtract it from the means sample mean. You might get some lower bound and might get some upper bound. This is the variation, so this error might be because of sampling bias. So after extending this sample mean with adding this margin of error, we have to check whether this upper bound greater than this population mean mu naught. So for left tail test, you have to calculate the upper bound and lower bound will be minus infinity. This confidence interval minus infinity to 98.7 does not include the population mean mu naught 100, so you will reject the null hypothesis. And another example, a company claims that their oats contains at least 15.5 grams of protein per 100 grams. Try to verify with following sample data. Population standard deviation is 2 grams, sample size 49, and sample mean observed here is 13.75 grams, and significance level here we need to check is 0.05. The data we have is extra mu naught is 15.5 grams. Formulate null hypothesis and alternate hypothesis. Mu greater than or equal to 15.5 grams. Within food, protein should be more. Maybe this is the standard 15.5 grams. More than this acceptable range. So that company is also claiming that their product has more than this grams of protein within their oats. So they are not differing with the research standard mu naught. So this is the null hypothesis. And alternate hypothesis would be mu less than 15.5 grams. Alpha here is 0.05 grams. we can use one sample Z test because we know the population standard deviation, which is 2 grams, and here sample size is 49, which is greater than 30. So we can go for this one sample Z test, calculate the Z statistic. Sample mean here is 13.75 and population mean is 15.5 grams. The difference is minus 1.75 and the standard error is 0.28571 and final Z statistic is minus 6.125. The sample mean 13.75 is minus 6.125 standard deviations from the population mean 15.5 grams. You need to find whether it is one tail or two tail test and find the respective Z critical value for desired confidence level. Here it is left tail test, so find the Z critical value for left tail test for 95% confidence level. Here confidence level 95%, alpha is 0.05. It is one tail test, so it will be 1.645. Since it is left tail test, so minus 1.645. Compare the Z statistic value with Z critical value. Z statistic is minus 6.125, which is less than 1.645. Here this is the critical value minus 1.645. Z statistic here is not minus 2.47, it is minus 6.125, which is far away from the Z critical value, which is in the rejection region. So results are significant. So you can reject the null hypothesis, means this Z score is very unlikely in this null distribution. So you will reject the null hypothesis. So the company's claim is wrong. This is the true. You can check same thing by using p-values also. Let's see by using p-values. This is a Z statistic. Find the probability for this Z value in Z table. Here we have this Z score up to -4 only. After this probability will be very less. So let's see probability at -4.09, which is 0.00002, means at this Z score you will have probability less than 0.00001. This is less than or significance level 0.05. So results are significant. You can reject the null hypothesis. The company oats have unusually low protein when we compared it with the mean value 15.5 grams at alpha 0.05. Let's see by using confidence intervals also. This is also left tail test. You have to find the only upper bound. Let's calculate lower bound and upper bound and replace lower bound with minus infinity. Since it is a left tail test, means one tail test, take the Z critical value for one tail test. For 95% confidence level, Z critical value for one tail test is 1.645 and our sample mean is 13.75 plus 1.645. Sigma here is 2 and sample size is 49. So if you calculate this value, lower bound will be 13.3 and upper bound will be 14.2 grams. You have to consider only upper bound, so replace this value with minus infinity. So your confidence interval range is from minus infinity to 14.2 grams. This is your sample mean 13.75. But population mean mu naught 15.5 grams, which is not within this confidence interval range, so we will reject the null hypothesis. The company oats having less protein than this 15.5 grams at alpha 0.05. Let's see one more example. The wine manufacturer claims that his wine has at most 19.8 ppm impurities in barrel of wine. You try to verify this with following data. Here sample standard deviation S is 3 and sample size 144 and the sample mean here is 20 ppm and we need to test this hypothesis at alpha 0.10 means 90% confidence level. Here mu naught is 19.8 ppm. First formulate the null hypothesis and alternate hypothesis. Wine manufacturer is claiming that they have at most 19.8 impurities within their wine, means maximum allowed level is 19.8. So they are also not differing with this standard mu naught. So it will be null hypothesis and alternate hypothesis will say that it will differ with this null hypothesis. So H1 mu greater than 19.8. We need to test at 90% confidence level, so alpha will be 0.1. Here also we can use one sample z test because we know the population standard deviation, which is 3, and sample size greater than 30. Here it is 144. So you can calculate z statistic by using this formula. Here sample mean x bar is 20 and mu naught is 19.8. 20 minus 19.8 is 0.2, and standard error 3 by square root 144, it is 0.25. Z statistic is 0.8. This sample mean 20 is 0.8. Standard deviations from this population mean 19.8. Fourth step, we need to find whether it is one tail or two tail test. Based on that, you have to calculate the Z critical value for desired confidence level. Here it is right tail test. Our confidence level is 90. So find the critical value 90 confidence level, and it is one tail test, so critical value is 1.28. Z critical value for it is not one tail. One tail test for 90% confidence level is 1.281. Compare that Z statistic 0.8 with this Z critical value. Z critical value here is 1.281, and this Z statistic does not falls within this rejection region. Since it is a right tail test, so rejection region on the right tail. This is not within the rejection region, so results are not significant. So you cannot reject null hypothesis. Means this Z statistic value is very likely in this null distribution, so you cannot reject null hypothesis. Same thing we can check by using p-values also. Let's check by using p-values. Here Z statistic is 0.8. Let's check the p-value for this 0.8 Z value. This is the Z 0.8, and this Z tables contains cumulative probabilities from minus infinity to up to this Z, but p-value means probability value from this Z to extreme end. Here end is infinity, but here we have cumulative probabilities from minus infinity to this 0.8. To get this probability, you have to subtract it from 1, so 0.788, then you will get 0.212. This is the p-value for this right tail. Here alpha is 0.10 and p-value is 0.212. P-value not less than this alpha, results are not significant, so you cannot reject null hypothesis. Let's see by using confidence intervals. Since this is also one tail test, so you have to find the Z critical value for one tail test. For 90% confidence level, alpha is 0.10, so one tail Z critical value will be 1.28. Exactly, it is 1.2816. Sample mean here is 20, and this is the Z critical value, and population standard deviation is 3, and sample size 144. If you calculate this upper bound and lower bound, the lower bound will be 19.679 and upper bound is 20.3204. For left tail test, we have only upper bound value. Here it is right tail test, so you have to consider this lower bound and replace this value with infinity. Then your confidence interval will be 19.679. Here this green circle is sample mean 20, and confidence interval here is upper bound here is 20.3204 and lower bound is 19.679. Since you should have only lower bound for this right tail test, so it will be positive infinity. This point 19.8 is the population mean, which is within this confidence interval range, so you cannot reject null hypothesis.